So today we're going to begin chapter 3, and we're going to talk about systems of equations. So you've probably done some of this in the past, so it's going to be a little bit of a review. So a system of equations is two or more equations with the same variables. So you'll have two expressions such as 3x plus 7y equals 8, or you may have 2x plus 6y equals 9. You would have to solve these equations for x and y. So a system of equations can either be consistent or inconsistent. Consistent means it has at least one solution, and an inconsistent system of equations has no solution. All right. There's also independent and dependent. So an independent system has exactly one solution. So you may have an equation that has a line like this and one that has a line like this, one solution. Dependent, they have infinite number of solutions. So that, say you're graphing, and your graph comes out like this, and then you graph the other equation, and it actually creates the exact same line. That means there's infinite number of solutions. So go ahead and pause the video and make sure you have all these down. And when you're ready to come back up, just go ahead and we're going to move on. All right, so the first way that you can solve systems of equations is by graphing. So if I have the equation 4x plus 3y equals 12, well, let's solve by using the intercept. Right, so if I want to find the x-intercept, well, recall when I'm crossing the x-axis, my y value is 0. So I'm going to let y be 0. So I'm going to cover up this 3y, that goes away, and I have 4x equals 12, which means x is 3. So I know I have the ordered pair 3, 0. I'm going to go ahead and graph that. And then for my y-intercept, I need to let my x value be 0. All right, so if I let my x value be 0, that goes away. And I have 3y equals 12. My y value is 4. All right, so I'm going to have my line. It's going to go like this, and it's going to keep going there, right? So try and draw your line as straight as possible. And that's our first one. The other one's going to be a lot easier if we solve for y. All right, so solving for y here, 4y equals 6x minus 1 divided by 4. Y equals 6/4, which reduces to 3/2. X minus 1/4. All right, so I'm going to be going to 1/4. There's my first point. And I have a slope of 3/2. All right, so if I went up to 3, about right here, and a little lower, about right here, and then over to maybe somewhere around there. And if I go up 3 from there, 1, 2, 3, over 2, about right there. And this is the issue with solving by graphing, is when you're graphing, especially something like 1/4, it's really hard to be 100%. So when I look at this, what I want to see is where does it look like they're intersecting? Where does it look like they're intersecting? Well, if I wanted to guess, that right there is 1, but it's past 1. So I'm going to just kind of play around and guess a little bit. It looks like 1.5, 2. And the way to verify that is plug those in to your equations and see if they work. All right, so if I plug it in, 4 times 1.5 plus 3 times 2, does that give me 12? Well, 4 times 3/2, or 4 times 1.5 is 6. A 6, yes, gives me 12. And if I plug it into the second equation, negative 6 times 1.5 plus 4 times 2, does that give me a negative 1? Well, negative 6 times 1.5 is negative 9 plus 8. Yes, I get negative 1, so it works for both of them. So my solution here is the ordered pair 1.5, 2. And see, this is where it gets tricky to do this by hand in the fact that how do I know that's exactly 1.5? So it's not always easy to graph by hand. So for this one, we're actually going to use a calculator. So the first thing I want you to do is solve both of these equations for y. Right, so if I'm solving this first equation for y, I have negative 3y equals negative 8x 36. Y equals, divide everything by 3, 8 thirds x, or negative 3 rather, 8 thirds x minus 12. That's my first equation. Solving my second equation for y, I come down to y equals negative 6x minus 21. All right, so pulling out your calculator, you have 8 thirds x minus 12. And negative 6x minus. All right, so if I were to look at the graph of this, oh, there's something wrong with my second equation. Oh, no, we're good. So I can't see it right now in this, so I need to adjust my window. I'm going to zoom, and I'm going to zoom out. So I can see their point of intersection. My calculator will actually find it for me. To do that, you do your second trace button to bring up this calc, and you see number 5. So it says first curve. If you move the cursor, you can see right now it's on my blue line. The second curve, move around, you see it's on my red line. Enter. It's going to give me a guess, ignore the guess. And you can see that my actual intersection here is at negative 1.03846 negative 14.76923. So that is not something you'd be able to look at a graph by hand and see very easily. So that's why your calculator is a huge help for us here. So if I zoom in a little, you can see that I wouldn't be able to guess that by hand, so your calculator is going to be an essential tool here. Like I just said, to find those, you enter your graph, your equations into your graph, and then you do second calc, and you choose number 5. Do that, right? So first way to solve systems of equations is by graphing. Next videos are going to give us some alternate methods.